Okay, recording now. So, today's lecture is classes and objects. We'll see how this goes. Okay, classes and objects. So, first talk a little bit about teaching philosophy, I guess. In Java, a lot of concepts are inherently connected. It's hard to teach them separately, and this is especially true for syntax, because even if you're doing the simplest possible code in Java, it involves classes and objects, it involves methods, execution flow, data types, right? What's an int, for example, and visibility. Why are some things public and other things aren't listed as public? If I try to explain every little detail of everything as I'm doing it, it'll be very confusing. So if there's something I haven't addressed yet, just go with it. Classes and objects, that's what we're covering this week. That's our big thing, and we'll cover methods and execution flow in that. Data types, we'll start getting into numeric types next week, like integers and such. And what else? Visibility, we push off towards the end of the course. For most of what we do, it's not going to be super important, but it is a core Java concept you should understand before we're all done with everything here. Okay, so the problem with this, of course, some concepts have to be introduced before I can explain them in any detail. So if you have questions, please ask, but sometimes the answer is I'm going to tell you, well, push the I believe button on that because, maybe we're going to address it in a few slides or the next lecture or whatever. Okay, but I can always give you a short recap of something if you need. Okay. There. Okay, so first question, what is a class? Well, a class is a category of things to be represented in Java. Okay, so it could be some tangible things like a person or a vehicle, or it could be intangible things like financial accounts or even special number types like very large numbers. So a class is just something in Java that it's a structure that enforces the rule that all objects of that class have the same set of methods and hold the same kind of data. That's the key thing. So we'll do a little example here. I'll stop the share for a second. Imagine, if you will, fire up Paint, and we'll share that. Imagine if you have a class, let's say birds. Okay. Now, there are many different kinds of birds, but the important thing to remember, this class can be anything you want. So let's give a couple examples. Number one, you might have a set of bird species, right? Like, I don't know, parrots, ostriches, and so on. Or you might have a specific set of individual birds. Okay? Either is fine, by which I just mean potentially valid in Java, as long as it fits your application needs. So, if you're running some kind of application where you track data about specific bird species, then yeah, you define a bird one way. If you're, say, a pet shop and you're tracking individual birds, or you're a vet clinic and you're, tracking their health, then yeah, you might associate them as particular individuals. But either way is fine. The point is, a class is simply a set of rules that describes the objects. So for example, suppose we're talking about individual bird species, okay? So suppose we're talking about species when we know a few things, right? We know some birds swim, some birds fly, some birds walk. I say probably all birds walk. That's probably a safe thing to say. Okay, and we could include those as methods. So in our root class, right, the fundamental class of all birds, call it the base class of all bird types, we could have a few methods, right? So we would say something like class, bird, and then in that, we could have a method. We could do, say, void walk, because all birds walk. Okay, again, we could have another thing, we could have another method if we wanted. Since most birds fly, we could have a fly method as well, right? And I'll put the squiggly brackets there. Okay, but of course we know not all birds fly. So we might even put in some data. We might have a Boolean. So a Boolean is basically a true-false variable. Boolean flightless. Okay, this would say every bird could be flightless, maybe as a species, right? So for example, penguins are considered flightless. Kiwi birds are considered flightless. Chickens are borderline. They can fly a little bit. I'm not sure if we would consider them truly flightless or not. Okay, but they're sure not going to do much more than fly up into a tree. Okay, so we could have that. The point is, every bird object belonging to this class would follow these rules. Okay, so if we design a bird object, if we create a bird object, it's always going to have a fly method and a walk method, and it's always going to have a Boolean variable called flightless. Okay, the point of this, so if I create a bird object, right, let's create a bird kiwi equals new bird. Okay, so then kiwi is an object of class bird. Okay, it's an individual kind of bird. What do we know? Well, we know I can always call the method kiwi.fly or kiwi.walk. Can always call these methods because I know, number one, all kiwi, right? This kiwi object is a bird. And number two, all birds can fly or walk, right? They have the methods, have those methods. So that's the importance of this. It greatly simplifies writing our code. If I have this bird class, I automatically know Kiwi's a bird. It's going to have certain methods. It's going to have this flightless Boolean variable. And so I don't have to worry when I'm writing my program. I don't have to check and see, oh, is a Kiwi able to do this? I know it can because a Kiwi is a bird and birds have those methods. Okay, that's the key point. So I'm going to pause the sharing for a second. I'm going to pause the recording again. We are recording again. Here we are. Okay, and we'll go back to the slideshow. Okay, so that's what we know. We know what classes are. We know what objects are. Wonderful. Okay, so class examples, right? We already gave some, but again, follow-up examples. Suppose you had a class vehicle. Depending on what you're doing with the application, you would represent the vehicle differently and track different data about it and have it do different methods. For example, a self-driving vehicle would be very different from inventory at a car dealership or military vehicles that are, carrying ammunition and stuff like that. So depending on your application, you might model them differently in terms of data, in terms of actions, right? So a self-driving vehicle would need some methods to gather information about the world around it so it doesn't crash into things. Inventory at a car dealership, you're going to attach things like the price, when it arrived, if it's linked to a particular customer, things like that. Okay. Now, class data. Any data that's uniform across all objects of a class should be stored at the class level. For example, suppose you have a standard interest rate for a savings account, right? Suppose you give like 0.1% interest on it. Well, if you have an individual value for every object of that class, number one, it's going to waste a little bit of memory space because you have to store a whole bunch of those values that are all going to be the same anyway. But the more important thing is that those values could somehow change. There could be some flaw in the code where something allows one of those interest rates on one of those objects to change. But if as a matter of policy, you want to ensure that they all have the same interest rate, easiest way to do that, the most effective way, is just to code it at the class level and say, for this class, there's going to be a single interest rate, and we use the magic word static for that. Okay, so anytime we have a value that's invariant across objects of a class, meaning all objects have the same value for it, we identify that with the word static. Okay. Same thing with methods. You might have methods that exist at the class level, right? They're not applicable to individual objects. They're applicable to the class as a whole. And generally those mean methods that are somehow affiliated with class data. For example, you wouldn't want an individual customer account to go in and affect that interest rate, right? You wouldn't want a user to be able to log into your system and independently say, you know, I don't think this this savings account is paying enough. I'm going to jack that interest rate up to 5% a year. You would want to stop that. So you put in a method that operates at the class level so that the individual person, right, the individual object will not have access to that. Okay. So having said that, it is often possible to write code where individual objects can access static class variables or class methods, but you generally don't want to include that. You want to, the proper way to do it is to access those specifically through the class itself. So we can do that. We can pop over to Eclipse for a moment. I'm going to do a new share, so I'm going to go to Eclipse. Okay. So I'm going to make a little demo here. I'm going to create a class, and you can follow along or not. So I'm going to call this bank account. Okay, because always use a bank account class, whatever. Let's do, actually, let's do savings account. Let's stick with my example. Savings account, boom. Okay. Now, there's going to be two things in a savings account, right? We'll say every savings account has a string for customer name and an int for the balance, right? Those are pretty straightforward. But I'm also going to put in another one here for the interest rate, right? So static interest rate. Okay. We'll just leave it as that. Why am I getting, oh, static int. Okay, I'll do a double. In fact, I'll do a double for the balance as well. Okay, a double is a kind of floating point number, so it could be like 1.0, things like that. So I'll use doubles for those today. Okay, so this one, static, so it applies to all savings account objects. For example, if I do a main method here, right, you'll also notice that the main method itself is static. Public static void main string array args. Okay. Interest rate equals 0.1. So if I want to create a new object, okay, let's make a new object of class savings account. So I'll call it savings account SA1 is a new savings account. Okay, it's automatically going to have a value for interest rate. Right, so I can do that. I can do system.out.println, this index thing, println SA1 dot interest rate. Okay, let's do that. Okay, this is just proving that it works the way I say it. So this is going to be the interest rate for that object, which it automatically gets from the class. Ta-da, interest rate 0.1. However, you do the same thing by referencing the class itself. Okay, the interest rate savings account dot interest rate. So again, the dot notation, the dot here shows that interest rate belongs to the entire class. So again, you can run this, and same thing, it's the same number. Okay. Now, if I try to do a method here that says change the interest rate, so I'll do void update interest rate. If I do it like this without static, it belongs to a particular object. I could call up, say, SA1, and I could call the update interest rate and send along a number, right? So I'll do double, I don't know, IR. But I don't really want to do that. Sorry. We'll do, say, 0.2. But I don't want the individual object to do that. It doesn't really make sense, right? What I want to do instead is make this static. If I make this static, it doesn't invalidate the code. SA1 is a member of the class and can still access this. But if you look closely, you'll see I have a little light bulb warning in the margin. It says here, static method, update interest rate should be accessed in a static way. That's what I'm saying. It should be savings account dot update interest rate. And then the warning goes away because I'm doing it the way I'm supposed to. Okay, so in general, if you're accessing static variables or static methods, you should be doing them from the class itself. Okay, if you're talking about object methods or object variables, they belong to individual objects and you access them through the object reference. Okay, we'll pause it for a second. If I can figure out how to do that, there we go. Stop share. There we go. Okay. So we talked about this static stuff. So we've gone through that. Now here's some simple code examples. So first off, for classes, remember Java is case sensitive. So the word class, lowercase c, indicates that a class name follows, while the word class with a capital C is the actual class's name. So here, public class, capital C class. The code is wrapped up in these squiggly brackets, and then within here I have a couple statements of comments. So by convention, when you're writing a class, you do data fields first, and then subsequently any methods will be ordered alphabetically. That's just a convention. Java doesn't make you do that. You can scramble up these things anywhere you want inside your class definition, but in an organizational setting, it's good to know quickly where things are. Okay. So the syntax for codes, the class header and everything inside the braces is part of the class definition. So essentially everything inside the definition is, everything inside the squiggly brackets is the definition for this class. It's kind of that simple. I don't have much more to say about that. Okay, a couple of quirks when you're coding in Eclipse. Java's a quirky language, so you got to get these quirks out of the way. So number one, when you're writing a new class in Java, the class name must match the source code file name. Okay, so if I create a file, class dot, say bird.java, that has to be the name of the class, has to be bird. And another quirk, a single file can hold multiple classes, but only the one matching the file name can be public. Okay, so I could have a public class bird and then other classes that are private or protected or what's called package private. That's the default without a visibility modifier. I could have other visibility level classes in there, but only the one that's public, that only that class could match the file name. So that's a quirk there. So again, if you're coding in Java, you have a pre-existing file and you say to yourself, wow, I want to change that file name, change that class name. You can't just go through the IDE to do that. Okay, you have to create a new class, copy most of the code in there, and then overwrite the class name. Okay. Now, class methods. Okay, so the starting point for any Java program is a method with this very specific syntax, which we just saw a minute ago. Public, static, void, main, and then string, array, args. These square brackets here, that is an array. It means a stack of the same type of data. So a string array is a stack of strings right? 0 or more strings, and individually they're referenced. We'll talk more about arrays, but that's all it is. Args is a set of text values that I can send along when I start the program that potentially specifies how the program runs. So this method main contains any code that's going to be executed, like creating new objects or calling other methods. Now, any class can have this main method, but you have to designate one specific class as the entry point for the program. So I'm going to show you how this works in Eclipse. Let's go back here. We're going to go over to Eclipse, talk about this main method. Okay, so here, right, I have my main method starting on line 7, and that's where that is. If you wanted to, you could go through this run dialog. It's a little bit more complicated. So if you wanted to, you could set up run configurations here. Ta-da! And you can have a bunch of interesting stuff here. So for this, the 2 Java applications I have, these are the 2 ones I have that have a main method, right? Server app that we did on Friday had a main method, and savings account, which I just did today, has a main method. So I could launch either one of those. Now, if I wanted to start my program with some particular values, I could send along program arguments. I could send basically a stack of text through that and have some method at the start of the program to parse it out, how it's going to run. I can also have these VM, virtual machine arguments, and I can do things like a specific amount of memory for the program to run. I could say it has a minimum amount or a maximum amount or both. So can do that. Okay, so if you want to go through that, you can do it. You can also say, just type in by hand. You could search for all of the main methods within that folder. I can pick any one of them. Okay. So anyway, as we recall from the other day, regardless of where the main method is located in the class definition, that's going to be the starting point for the program. And I'm going to execute all the statements in there. And then when I get to the end of it, right, I'm going to know system.out.println application ending, right? It's done. The last statement in the main method, it was going to be what ends the program. Ta-da, all done. Okay. So moving on, we'll get back to this lecture then. Okay. So main method syntax, right? Within our class, this class has a main method now, public static void main string array args, and whatever code I want to start the application running goes in that main method. Okay. Method syntax. We're going to break this up a little bit, and this will probably be the last big topic we do today. So every method header has 3 things. When you see those magic words like I had here, this is the method header, okay? So the part in squiggly brackets is the method code. This part before it is the header. So we have a visibility modifier public, we have static, we have a return type void, we have the method name, and then in parentheses, we have any parameters that the method expects to receive. So every method header has to have 3 things: return type, what data the method sends back; the name, which can be anything except reserved words. For example, you couldn't use lower C class for a method name, or you couldn't use just a set of numbers for a method name, okay, or a bunch of weird special characters. And parameters. Parameters are the data inputs the method expects to receive. Like in the example I talked about in the chat box a little bit ago, we had a method add that accepted 2 ints, x and y, and then returned their sum also as an int. So in Java, all the action happens in methods. When a method m gets called from the main method, it's the same thing, right? Within that method, all the statements in m would execute sequentially. So we'll start with the first statement in m. Once I call m, that may itself call other methods. Eventually, though, we'll come back to that last statement in m, and there'll be a point where we return. Either there'll be a return statement in the method that explicitly says, here's the kind of thing that you return, what value you return, or there won't be, and I'll just return back automatically because I've reached the end of the method. Okay, one of those 2 ways. And then the execution returns to the main method at the statement following the method call, right? And again, the flow is going to be exactly the same if m itself calls another method. So I can show you that back in Eclipse here. what we did the other day. Okay, so if we go to our server app class, okay, here we had the main method. The very first thing we did in the main method, we create the new object. So it jumps out of there, the execution flow jumps over to customer accounts constructor method that creates the new object. It does that, it comes back, it goes to system.out.println. Well, it's not listed here, but system.out.println is actually kind of a complicated method. So that branches off to a bunch of other things. Eventually though, it gets done with its stuff and it comes back. Okay, so at that point I call the next method here, c1.setUsername. So I bounce over to Joe's set username, I set it, I reach the end of the method, I return back, and then I again call system.out.println, do that, come back, I reach the end of the main method, and the program ends. Okay. So we're gonna come back here and share the screen. Okay. So arguments and parameters. With a method call, the program can send along values or objects. Those are called arguments. Something that you're sending is an argument. So when I call system.out.println, inside that method calls parentheses, I have whatever text I want it to print, right? I could have a string, I could have a number, I could have a reference to some content from an object, but any of those things that I'm sending along to the print method, those are called arguments. When the method executes, they get received as parameters, right? So you can think of that as the way I'm specifying the parameters of how the method will operate, specifically what data it has to work with. Okay, so arguments are stuff you send, parameters are inputs to the method. Okay, it can be a little confusing, so yeah, try to absorb that. Now, one key point, arguments have to be compatible with the parameters in the method definition. For example, if the method expects to receive a small integer, I can't send a large decimal value, or I can't send a text string, right? It's like the add method expects to get 2 integers, so I can't send along, you know, horseshoe and kiwi bird as arguments. It wouldn't make sense. What's the sum of horseshoe and kiwi bird? We don't know. Okay, I can do the math on 6 plus 7. That's why the types have to be compatible. Okay, so for now, we'll keep it simple. Only give examples where the arguments and parameters have the same type, but bear in mind that is a common source of problems, is that you have specified the method to receive one type of data, but somewhere else in the program, you're trying to send it a different kind of data. Okay, so I guess we'll end it with return types. This will be the last thing I'll do, and then we'll have some time for questions. So methods can return simple numeric data, objects, arrays, or even nothing, right? So the return type goes before the method name. Void, if the method returns nothing. There's a few numeric types. All the rest of these are going to be data types. So the method will return some kind of data. It could be a simple number. Those are all simple numeric types. It could be an object type that's going to be returned, like a string, or even an object. There's an object class. Or it could even be an array, right? So again, whatever data type there is, if it's going to be a stack of it, we follow it up with the square brackets. Okay. And interestingly, syntactically, a method that returns a value or object can be treated as whatever it returns. So I'll give a quick example of that in just a moment. We'll do a recap on classes though. Okay, so recap on classes. I know there's a lot of stuff I'm putting out here today. If you're keeping up with me, you should get these key things. Number one, classes are templates for making objects. Okay, that means they're cookie cutters. We want to make sure that all objects of a class have the same capabilities so that we can reference them generically. We don't have to worry, for example, that if we create a kiwi bird of class bird, that we won't have access to the same methods specified in bird. Okay, that's the key thing. So classes enforce uniformity of data and actions across all objects of that class. We know every object of a class will have the same kind of data, so we can be safe and confident referencing that data through the object reference. Likewise, same for methods. We can safely call methods of an object through that reference, and we know they'll be there. Okay. Interesting quirk that I haven't mentioned, static data or methods, they can be used by the program even if no object of that class has been created. For example, like the main method, right? Once we include a class in our program, the main method automatically exists because it exists by virtue of being in the class. That's how we can call the main method on a class, even though no object has been created, right? So it's syntactically valid to do it that way. All right, so last thing I'm going to do, quick thing here. I'm going to bump back to Eclipse. Somebody here in the chat has asked, what does double return? A double is a large floating point integer. Not a floating point integer, a floating point number. So it could be, the numbers are roughly between plus or minus 10 to the 308th. It's a potentially absurdly large number. Okay, but it can have a decimal. Integer types don't have a decimal point. Okay, so let's do, what did we have this example I was talking about just a moment ago? Sorry, I've lost my train of thought here. Return type. Oh yeah, return of value can be treated as whatever I return. Great. Okay, so we'll do that. So in our savings account, okay, if I want to do that, I could do, let's write up a quick method. And we'll do this. Void int, get interest rate. Oh, it does a double. Get interest rate, no parameters, and just return savings account dot interest rate. I don't know why it cut me off on the autofill there. Fine. Okay, so this is fine. I have this method, get interest rate. Okay, if I want to, I could do this. I could just print it out, right? So that's going to be, ooh, that's fine. I'm going to do one with a string. So string get customer name. This would be a better example. Okay, so return customer name. It's not a method. Okay, so this method here that I've done, get customer name, line 16, is just going to return the customer's name. So if I wanted to, I could do something like this. I could say system.out.println. Instead of saying, hey, return this particular string, I could just say sa1.get customer name. Okay, now if I hover over this, I hover over with the cursor, you can see it actually returns that string, right? So string savings account get customer name. So this object here is a string. If I wanted to be interesting about it, right, I'll do this. I could say length, and I could do this, right? I could call the length method of the string. So this part here, sa1.get customer name, since that method call returns a string, I can just treat that within the IDE as a string. And I can call the method that returns its length attribute and then return it. So if I do this, for example, sa1.customer name equals Doug, okay? Doug is going to be 4 characters long. So when I run this, it should say length is 4. Ta-da! And length is 4. Okay, so I'm going to stop the sharing here, stop the recording, and we'll do some Q&A.